Hi everyone, I'm P. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS College of Arts and Science, Coimbatore. In this previous lecture series video, we are going to discuss about the solutions of given linear programming problem by graphical methods. Already we discussed the maximization and minimization problem, how find the solutions of the two in graphical methods. So continuously in this lecture series video, we are going to discuss about the special case solutions of a given LPP by graphical methods and also the standard form of linear programming problem. So let us go to the video now. So the special case solutions of LPP, that means already we have maximization solutions of LPP and the minimization problem, how we find the solutions of LPP by graphical method. Continuously in this lecture series video, the mixed constraints, that is less than or equal to and greater than or equal to types are given. How you find the solutions of these type of constraints of equations using by graphical methods. So consider this example. Use the graphical method to solve the following LPP. Minimize z equal to 20x1 plus 10x2, subject to the constraints x1 plus 2x2 less than or equal to 40, 3x1 plus x2 greater than or equal to 30, 4x1 plus 3x2 is greater than or equal to 60. Definitely our decision variables x1 and x2 always positive, that is non-negativity restrictions x1 x2 are greater than or equal to 0. So what is the first step? We find the coordinate points of the given constraints. So before that, we make all the inequality considered as to inequality. Okay, right. So first, from the first inequality, that is x1 plus 2x2 less than or equal to 40, if we consider this less than or equal to equal. That is x1 plus 2x2 is equal to 40. By as usual, we find what is x1 x2 value from the first line. If x1 0, so we get 2x2 is equal to 40. So therefore x2 is equal to 40 by 2, that is equal to 20. From the second, if x2 is equal to 0, so x1 is equal to 40. So we get this 40 comma 0. Therefore the coordinate point of the first line is 0, 20 and 40, 0. From the second line, as usual, the inequality is greater than or equal to type, make it is to equal. So 3x1 plus x2 is equal to 30. We solve this. How we find the solutions of x1, x2? If x1 0, x2 is equal to 30. If x2 0, the x1 become 3x1 is equal to 30, therefore x1 become 10. Therefore, the coordinate point of the second line is 0, 30 and 10, 0. Next, the coordinate point of equation 3. So we have the inequality is greater than or equal to type, make it is to equal type. So 4x1 plus 3x2 is equal to 60. If x1 is equal to 0, x2 is equal to 60 by 3, that is equal to 20. From the same, if x2 is equal to 0, so 4x1 is equal to 60, therefore x1 is equal to 15. Therefore, the coordinate points are 0, 20 and 15, 0. So we fix all the points on the graph and we have what is a solution region. So from the first equations, we get uh, it is a 10 comma 0 fix here and the 0 comma 30 fix here. Join these two by a line, we get the straight line, and from the point 15 comma 0 and 20 0 comma 20 we fix that, and the third one is 0 comma 20 and 40 comma 0, we join this line, we join these 2 points by a line. In the first equation, it is less than or equal to type. Therefore, it is greater than or equal to type. So in this line, it is greater than or equal to type. Therefore, we consider the outside the region. And in this line is also considered as to less than or equals outside the region, and it is inside the region. So therefore, we consider this one. And we make it all the region as in the graph. First, we cut this line. We cut two portion. One is a below side, upper side. It is my minimizations. Therefore, it is a greater than or equal to type. We get in the line is also cover outside the region. Therefore, we have only this outside the region. So we neglect this triangle. And we cut this second line again. It is less than and greater than. So this line is also greater than. Therefore, we consider this region. And the third line is less than, therefore we consider this less than line. So we get the bounded region. Okay, so the bounded region. If it is less than outside the region, greater than, sorry, less than inside the region, greater than outside the region. This line is outside greater than, therefore it is outside. And this line is also greater than, therefore outside, but this third line is inside, less than or equal to, therefore inside the region. After cutting all the lines, we get the common bounded lines. This is the bounded lines. Therefore, it is our solution region. This solution is denoted by A, B, C, and D. The coordinate point of A is 15, comma 0. The coordinate point of E is 40, comma 0. And here we don't know what is point C and D. So how you find the C? It is intersecting of these two lines. Therefore, we take these two lines and solve the two lines. We get the coordinate point. So it is 4, comma 18. Okay. Similarly, what is this point? It is intersecting of these two lines. Therefore, we solve constant these two lines. Then we get the point 4, comma 12. Okay. So these are all the coordinate points. Substitute all the point to the optimum. We get the minimum value. So minimum is, that is 20x1 plus 10x2. So the coordinate point of A is 15, comma 0. Substitute here. We get 300. The coordinate point of 40, comma 0. Substitute here. It is 800. The coordinate point of C4, comma 18. Substitute here. We get 260. The coordinate point of 6, comma 12, substitute here it is 240. Among this all the value, the required answer is minimum. Therefore, among this all the value, the minimum value is 240 when x1 is equal to 6 and x2 is equal to 12. So that is a special case solutions of a given LPP with mixed constraints. Okay. So next we discuss about the standard form. Before that, it is important things. What is slack and the surplus variable of the given LPP? The slack variable is a non-negative variable added to the left side of the inequality of the constraints in a linear programming problem to convert into the equality. So an equality is given, we convert the inequality to equality. So left side we add sum of the constant, then it is equal. So the adding constant is called slack variable. For example, here x1 plus x2 less than or equal to 10. So here left side is minimum value, right side is 10. Therefore, we add some constant to the left side, that is some s1, then it is equal. So s1 is greater than or equal to 0, positive s1. Therefore, x1 plus x2 plus s1 is equal to 10. The s1 is positive. Here, the s1 represents unused or ideal resources, that is s1 is slack variable. Similarly, for surplus variable, what is surplus variable? Surplus variable, a non-negative variable subtracted from the greater than or equal to constraints to convert it into an equation. For example, x1 plus x2 greater than or equal to 8. So here left side is greater. Therefore, we subtract some variable here. So constant s2 is subtracted from left side. Then it is equal. Then it is converted to equal. And s2 is greater than or equal to 0. Here s2 represents excess over the minimum required level, that is slack and the surplus variable. When we add the inequality left side we add sum of the constant, then it is slack. We subtract greater than or equal to type to the left side, then it is surplus variable. It is slack and surplus variable. And next, what is standard form? The standard form is LPP record standard form is a function. The optimum must be maximum. If it is minimum, we convert by multiple the function by minus. That is minimum z is minus maximum of minus z. And all constraints should be equal type with the non-negative left-hand side constraints. All the decision variable must be non-negative. Slack surplus variable added to convert inequality to equality. So these are all conditions for standard form. For example, consider the given problem to standard form. The maximum is based on 120x1 plus 150x2 subject to the constraints is less than or equal to. So we make it all this less than to equal. Therefore, we add in the first inequality is less than, second inequality less than, third inequality is also less than. Therefore, we add some of the constant to these three inequalities. Therefore, we add some s1, s2, s3, that is slack variables. So we add three slack variables, then it is make it to equal. So from the first equation, we add some slack s1. So after that, we get so after that we get 2x1 plus 3x2 plus s1 is equal to 30. 2x1 plus 2x2 plus s2 is equal to 16. 16x1 plus 4x2 plus s3 is equal to 64. X1, X2, S1, S2, S3 all are greater than or equal to 0. Before that, the maximum is value is, we add the slack. So the cost of value of slack is 0. So 0 S1 plus 0 S2 plus 0 S3 added in this objectives. So we get the form. Maximum method is 120x1 plus 150x2 plus 0x1 plus 0x2 plus 0x3. Subject to the constraints 2x1 plus 3x2, we add some slack s1, then it is make it equal. And the second is also add slack, it is make to 16. Third is also add slack s3 is equal to 64. All the variable are positive. So x1, x2, s1, s2, s3 are greater than or equal to 0. So definitely this everything has 0. Okay, right. So that is a standard form. Similarly, one more minimum. In the minimum case, it is greater than. So therefore, left side we subtract some of the variable. So if it is minimum, we convert the minimum to maximum. How it is? Maximum z dash or z star is minus z. Therefore, the cost of function is minus 300x1 minus 500x2. Subject to the constraints. The first inequality, it is greater than or equal to type. Therefore, we subtract some of the variable minus s1 is equal to 1000, and the second is also greater than, so subtract some constant value here, it minus s2 is equal to 800, and the objective functions become 0s1 minus 0s2 or plus 0s1 0s2. Therefore the standard form is maximum z star is minus 300x1 minus 500x2, subject to the constraints 20x1 plus 40x2 minus s1 is equal to 1000, and 25x1 plus 20x2 minus s2 is equal to 800, and the non-negativity conditions x1, x2, s1, s2 all are greater than or equal to 0. So it is a standard form of LPP. This standard form is used to find the solutions of LPP using by simplex method. So that purpose we discuss this standard form. So we discuss what are the solutions to obtain the obtain the solutions of a given LPP using the simplest techniques. So we we discuss that in next video. So bye. Thank you.